All right, in this screencast, we're going to look at combined gas law, which is a combination of all three gas laws that we've looked at so far. And you would use combined gas law if you were considering this hot air balloon. You have pressure, temperature, and volume changing for the whole balloon as you change both variables. All right, in combined gas law, you have pressure, you have volume, and you have temperature all changing, and these are all your variables. And you are holding amount of gas constant, so moles is constant. Okay, now, and remember, temperatures have to be in Kelvin, and it does not matter for pressure and volume what units, as long as the units agree. It's important to make sure that you have atmospheres on both sides, or kPa, or milliliters, whatever you choose. All right, so this is the combined gas law, and it combines all three gas laws that we've learned so far. So you have Boyle's law, which is P1V1 equals P2V2. You have Charles' law, which is V1 over T1 equals V2 over T2. And you have Gay-Lussac's law, which is P1 over T1 equals P2 over T2. So what we're going to do is we're going to combine all three of these equations. So if you look, something that's common is they are all set up as something equal to something over another fraction, okay? So you have your pressures are always on the top, your volumes are always on the top, and your temperatures are always on the bottom. So in the combined gas law, we're going to put our temperatures on the bottom and our pressures and our volumes on the top. So as you can see, you have a couple of things going on here. You have Boyle's law, which is there. You have Charles' law here, and you have Gay-Lussac's law there. So you have all three laws combined into one equation. So when you're looking at this, depending on how you want to approach the whole gas law concept, is you can memorize 4 equations, or you can memorize 1 equation. And if you memorize just 1 equation, it would be the combined gas law. And whatever variables you don't have any numbers for in your problem, they're held constant and you don't include them. So if you were doing, a Boyle's law problem and they gave you pressures and volumes, you would recognize that temperature was not filled in and you just wouldn't use it. So you can memorize 4 laws, or you can memorize 1. Whatever suits your way of learning a little bit better would be whatever works for you. All right, so here's a sample problem. A balloon has a volume of 500 liters at 25 Celsius and standard pressure. What is the new volume? We're going to look for the new volume at 0 Celsius and 725 millimeters of mercury. So we have some information here, and I always identify what they're giving me. So we have volume 1 is 500 liters. We have standard pressure, and that would be, well, they give me some millimeters of mercury, so this is going to be 760 millimeters of mercury. I have a temperature at 25 Celsius, and so I have to add my 273 to that, and I'll get 298 Kelvin. I have a V2, which is what I'm looking for. I have P2, that is 725 millimeters of mercury. And I have a temperature of 0, so we have to add our 273 to that as well, and we get 273 Kelvin. Okay, so we're going to plug all this in. We have 500 times 760 all over 298 equals V2 times 725 over 273. Now, this is a lot of math, and some people would find this very intimidating, and it's still cross-multiplying, except we're going to multiply here and then down there, and we're going to multiply here and then down there. Whenever you do that, you would be taking the 500 times the 760 times the 273, and you get a number, and you're going to take your 298 times the 725 and get a number, and then this second number that we just found, we are going to divide it into the first number. As a result, our V2 is 480 liters. All right, this is homework. Remember, we're going to submit this into the assignment for combined gas law in Schoology. Make sure that you set up the problem, show your work, and submit your answer. I'll read it to you. It says a tire has a volume of 400 liters and is at STP. What is the volume when the pressure changes to 90 kPa and 30 degrees Celsius? So you are solving for V2 in this problem. So again, make sure you set up and show your work, and submit all this into the combined gas law assignment in Schoology.